Hi guys, today is Unit 7, Day 2, Reflections and Rotations. Alright, as a really quick review, we're going to be talking about two more transformations. Now, transformation is an operation that changes a geometric figure. We've already discussed translations and dilations. And we talked about how translation is a change in the location of your geometric figure, and that the dilation is a change in the size of our geometric figure. In this lesson, we're going to talk about reflection, which is like a mirror image, and a rotation, which is a turn or a pivot. All right, so let's get started with a reflection. A reflection is a flip, or like the mirror image that creates a mirror image. Now, the line of reflection is the line across which the figure is reflected. So if we look at this picture on the right-hand side, we can see that it's reflected across our x-axis right there. Each point of the pre-image, which is our top triangle, is equidistant, which is the same distance from the image itself. Which means if we look at point A and A prime, the distance between A and the line of reflection is the same as the distance between A prime and the line of reflection. And that's the same for every point along our triangle. If we look at point B, it has 4 units away from the line of reflection, and then B prime is also 4 units away from the line of reflection. And then same with C and C prime. All right. The most common lines of reflection that we're going to be working with is our x and y axis. We're also going to be talking about the equation y equals x, which is when you have that kind of a line. There are other lines of reflections, but we probably will not be discussing them in this class. Now, similar to translations, reflections are also congruence transformations, so that the image and the pre-image have the same size and shape. Real quick, I want to derive our reflection rules. All right, so if we look at a point, let's say 2, 3 right here, we know that our first number represents our x value and our second number represents our y, and we want to reflect it across the x-axis, which we know is this one right here. So I'm going to draw that line in red. We discussed that all of the reflections are equidistant from the line of reflection, which means if it is 1, 2, 3 units to the line of reflection, then the image will also be 1, 2, 3 units away from the line of reflection, which gives us this point right here. So A here becomes A prime, and that coordinate point is 2, -3. Now, what you can recognize here is that our x value stays the same, but then our y value becomes negative. And that's always going to be the rule if it reflects across the x-axis. Any coordinate point on your geometric figure, x, y, will then become x -y. So your x value will stay the same, and your y value will become negative. So the way that we can apply this rule, for example, if we had 1, -7, well, then the 1 would stay the same, and then the -7 would become negative. So negative and a negative becomes a +7. All right, so that's how we apply these rules. Now, the reason why we're deriving each of these rules is because there's a lot of them, and it can be really easy to mix them up, because it's really just a matter of the order of x and y and negatives and positives. So this way, you're able to use common sense. You have a process for which, oh, I don't remember if that's a rule for x-axis or y-axis, how you can figure it out yourself. All right, so let's do the same thing if we're reflecting across the y-axis. We'll use the same coordinate point, 2, 3. But this time, we're going to reflect across our y, our vertical axis here. Now again, we want to be equidistant from the line of reflection. So this way we're going to go left and right. So we're 2 units away from our line of reflection. So we need to go 2 further, and then we end up with this point right here, A prime, which is -2, 3. So in this situation, our x becomes negative, but our y stays the same. So x, y becomes -x, but the y stays the same. So again, if we have a coordinate point 4, -3, well then the x becomes negative and our y stays the same. Okay? Now let's take a situation y equals x. I'm just gonna draw that line for us real quick. So that line is y equals x. And let's have a coordinate point right over here. And that coordinate point is 2, 1. All right, now we're still gonna go what is equidistant from the line of reflection. So here we can see it goes kind of like half diagonally. So we're gonna go another half diagonally, and then we end up with this coordinate point. So A again goes to A prime, and that coordinate point is 1, 2. So now we have our x and y becoming y and x. We're flipping those two values. So the rule for when it reflects across y equals x is that x, y becomes y, x. If we had -2 and 3, it would become 3, -2. All right, so just summarized right here, we have all of our reflection rules, right? So x-axis, y-axis, y equals x. Let's go through an example where we're using this rule. Now, the first thing that I always do for these questions is list the coordinate points of our pre-image. E, F, G. And then we know that it's asking for what are the new coordinate points of the image, EFG, E prime, FG, E prime, F prime, G prime, when it reflects across the y-axis, the x-axis, my apologies. So if we know this is our x-axis, we're looking for when it reflects across that line right there. So our image, our pre-image, point E is at -4, 3. Our pre-image point F is at -4, 5. And then our pre-image point G is at 1, 1. Now if we look previously, the rule for our x-axis is xy goes to x, -y. So xy goes to x, -y when it reflects across the x-axis. So we're going to apply that here. E prime, F prime, G prime. So our x value stays the same, -4, and then our y becomes negative. X stays the same, y becomes negative, x stays the same, y becomes negative. And now we have the coordinate points. We can graph that point real quick. Let's take a look at what that looks like. So -4, 1, 2, 3. This is our E prime. -4, -5 is F, and 1, -1 is our G. So if we put that together, you get that shape right there, which you can tell looks like it is the mirror image of our pre-image EFG. And you can tell that each coordinate point is equidistant from our line of reflection. Okay, so we know that we got the right answer there. Take a bit of time and work through these 4 independent practice questions. And now we're going to talk about rotations. A rotation is a turn, a spin, or a pivot around a fixed coordinate point. Now the center of rotation is the fixed point about which the figure turns. For this class, our center of rotation will always be the origin, which is our point 0, 0. Now the angle of rotation is always counterclockwise unless it specifically says otherwise. So if we can imagine a clock, 12, 3, 6, 9, we're gonna go in the opposite direction that a clock normally goes, which means counterclockwise is this direction, okay? In our rotations, we talk about it going counterclockwise. Rotations are also congruence transformations, so the image and the preimage have the same shape and size. What you'll realize is of the 4 transformations we discuss, dilations are the only ones that are not congruence transformations, right? Dilations become bigger or smaller, so their size does change. But otherwise, our translations, reflections, and rotations are all congruence transformations. They do not change their size or their shape. Now, similarly, I want to go through and derive our rotation rules. Now, in my opinion, these 3 are the most confusing, and that's really why I want to go through this derivation, because I get them all mixed up. I try to memorize them, and I have a really hard time with that. So I figured out a way that helps me come up with this rule when I need to use it, so I don't have to just, brute force memorize these for the rest of my life, because it doesn't work very well for me. As we talked about before, we said that the origin is our center of rotation. That means all of our rotation is going to happen around the origin. Now let's talk about a coordinate point here, 3, 1. All right. And what I want you to imagine is a circle where that red dot is the center. We have a radius that goes from that center to the point 3, 1, and we're going to draw a circle that goes around like that. So we're going to have, bear with me, ta-da, a circle that looks like that. All right. If we rotate 90 degrees, we're going to end up with this as our 90 degrees, and we have a coordinate point right there, right? This is 1/4 of our circle. What you can see is, well, that coordinate point lands on -1, 3. So here it is -1, 3. So our x and our y value, well, now they switch because y comes first, but not only do they switch, but our y is negative. So it becomes -y, but our x value does not become negative. So a 90-degree rotation, x, y, goes to -y, x. And I think this is confusing, so I'm going to go through it one more time. Our x and our y value, they flip, so they're in their respective positions, so 3 and 1 switch, and then our 1 becomes negative. All right, that's what happens when we go through a 90-degree rotation. And again, this is all going counterclockwise. All right, now when we think about a 180-degree rotation, we can take that entire thing, but do it one more time, right? So we're gonna go another 90 degrees, which will end up with that line right there. Here's another 90 degrees. And that coordinate point, you'll see, is -3, -1. And here you can see that our x and our y, our original point, now both of them are negative. So it becomes a -x and a -y. So x comma y goes to -x, -y. All right, that's what happens for a 180-degree rotation counterclockwise. All right, 90 degrees plus 90 degrees is our 180. Now 270 is if we were to add one more 90-degree rotation. So we're going to take, again, that circle that we have here and then go through one more time. So now if we do one more 90-degree rotation, we'll end up with that point right there. And we know that that coordinate point is 1, -3. So again, compared to our initial point, 3, 1, now we've switched the order again, but now our x is negative. So y is still 1, and then our 3 becomes a -3, so it becomes a -x. So now when we do a 270-degree rotation, our x comma y becomes y -x. And those rules are again summarized right down here. So 90 degrees, 180, and 270. Let's see how we can apply these rules in this teacher example here. So we're given a triangle EFG. It is rotated 270 degrees. And this one tells us counterclockwise. If it didn't say counterclockwise, we would still assume that it's counterclockwise. And then what are the new coordinate points for the image E prime, F prime, G prime? So we'll say this start the same way. Our pre-image coordinate points E, F, G. And this shape is actually the same as the one from before, so I'm just gonna put down what we had before. And now our image rule is gonna be our 270-degree rotation. So all our x and y coordinate points become y -x. So in applying that rule, E prime, well, we're gonna flip the order. So 3 is gonna come first, and then our x value, our -4, becomes negative again. So -4 becomes a +4. We're gonna switch the sign. Do the same thing for F prime, right? So the 5 will stay the same, and then the -4 will become negative. So a -4 becomes a +4. And then our G prime, well, we're gonna flip them, and then our x value becomes negative. So it'll be 1, -1. All right, and those are the coordinate points of our image. If we were to graph them, just so we can see what it looks like, we would have 3, 4, which is up here, E prime. We would have 5, 4, which is right here, F prime, and then 1, -1 right here, which is G prime. And if we were to draw that triangle, we would see that it is a 270-degree rotation, like that. And again, here are our answers. So take a little bit of time and try these independent practice questions on your own.